while watching a video recently. I subscribed to a channel on YouTube called Sunny Farms, and it's a father and son cattle ranchers, and they were calving, which means helping the cows and taking care of the calves as the youngsters are born. And they thought they would hold a small contest, which was kind of interesting. And what they wanted you to do was guess in the comments of a YouTube video what exactly the calf's weight would be in pounds. And I thought that was interesting, but I don't know anything about cattle ranching. There was just no way I would come up with anything reasonable. So I thought, wow, I wonder if the central limit theorem and the law of large numbers could help me. Everybody knows about the story about coin flipping and jelly beans. And, you can see by the link I've got here, that's one of the more interesting ways to display and show the law of large numbers. As the number of independent guesses go up, the accuracy of the guess should get better. And the central limit theorem says those guesses, assuming they're independent, which, given that it's YouTube comments where they're at, independence might not be a good assumption here, but we'll test that in a minute. So I've got a link here for the central limit theorem. And the first thing I did, since I didn't have this Python program written yet, was go out and use good old-fashioned state-of-the-art Excel. So I went through the comments, put down all the guesses. You can notice that I've got 40 of them, and my average was 61.5 for those 40 guesses. So that's pretty good. I know after the contest is over that the accuracy of that guess was 95%. So given the fact that I know absolutely nothing about ranching and that these were just an average of 40 guesses, that's a pretty good number, but I'm pretty sure we can do better than that. And in comes a really cool YouTube or video that I saw by a gentleman who used something called Selenium to work within Python and scrape the data, the comments out of YouTube videos. This specific application was just perfect for what I needed. This is what I needed to do. So, you can go to this link in PyPy, and it has all the documentation for Selenium. And in essence, what it was written to do is to be a web testing package. Test out your web applications and make sure everything's working correctly. It's funny, I used to write applications like this. I think they called them robo-reps or things like that, using APIs from tools like Attachmate Extra to emulate the actions that somebody would take while interacting with a screen at work. And I think a lot of people call these robo-reps now, and I think there's some commercial packages that do this still. Altair has a package called Monarch, which does very much the same thing. Automated interactions for screens. So with this Selenium package and some Python, I went ahead and copied a chunk of this program from the gentleman's link, which I'll provide. Links to all of this will be provided in the comments, which I'll provide. And all I had to change was where I installed the Chrome driver, which is in essence a testing interface for Chrome, and what actual YouTube video I wanted to read. So you can see I import the time function because we're going to do some waiting around. I import all of the Selenium tools that I'm going to need, and we're going to create our list object. And let's go ahead and run this, and you can see what's going to happen. So there it is. There's the actual video popping up. And of course, you're going to have an ad. Skip the ads.
Good morning, cows.
And you can see that it's actually scrolling through and copying the comments to that list object. So I'm going to go up here real quick.
The side gate never got shut yesterday. There's critters in here that should be in there.
Oops. I'm going to keep playing. I'm just going to shut off the sound so it's quieter. But we're going to let this run, and you can see it's just scrolling through and copying those comments. So we're going to leave this run for a little bit and come back, and then we'll take a look at the data that we got. So the actual script is completed. We've pulled all of the records, and you can see that our list actually has 864 different comments. So let's pop that open real quick and take a look. Yeah, and you can see that the list has a whole, the entire comment in it. Oh, you can see there's a guess, 54 pounds. And, you know, if you kind of scroll through, you can see a lot of people never guess, some people do. You know, some of the things that I noticed were that all of the numeric values that showed up in the comments weren't necessarily a guess. I think some of them were actually years, some were percentages. It's, you know, you get a wide range of comments on a YouTube video. So they could run quite a range. And, you know, see, outstanding in your field, DAD level 1000. Well, that's really not a guess about how the weight of the cow. That's just a comment expressing their love of Brian Sonny, which he's a great guy, by the way. So, you know, we've got to do a little editing. Here's some other numbers, you know, at 1120. So, you know, they're not all guesses. And so we got to do a little data cleaning. So let's talk about that. You can also see that I created a data frame up here and converted that data into a data frame, gave it the name comment. And if you do a head on that, you can see that the information's down there. Now we got to do a little data cleaning now. So one of the favorite things that I use, and I use it quite a bit, is something called a regular expression. And really what's going on here is I'm scanning through those strings. I'm creating a new column in my data frame called comment underscore number or com underscore numeric. And I'm going to try to pull out the numeric values out of those data frames. And, you know, we'll see that I'll get, you know, some of those DAD level 1000. We'll get other things that aren't really guesses. So we'll have to clean that up a little bit more later on. But learning how to use regular expressions can be very confusing. So what I like to do, I actually use a website called Reg Ex 101, and it's regex101.com. Once again, the links will be in there. And you can see I put that regular expression in here. And then you can put test strings in. So I've got 205.5, and this is a cat weight of 20 pounds. And you can see that it's actually getting a match and putting out the value that that regular expression is going to return. What's even better is you actually get an English language definition of what the regular expression is doing. Whether or not it's greedy, which can be a little bit confusing. I tell you what, if you've got to learn regular expressions, regex101.com is the way to go. It's the way to test. And I can't imagine trying to do regular expressions, not having grown up doing them without it. So definitely take a look at Regex 101. It's a great tool, and I use it all the time. So let's do some data cleaning here. Let's go ahead and run all of this. And I'm going to take that common number, and then I'm going to create the types, and then I'm going to convert the common number to a numeric value, because I need it to be a number to do the things that I want to do later on. So let's go ahead and run this. And, you know, you can see that our common underscore int is now a float. and that's a numeric value that we can actually do math on, which is good. Now right here is where we try to make the best of what we'll call data cleansing. So I know that there are some values in there that are just ridiculous, like years. I also know that there are some values in there that don't have anything to do with the calf guessing that are very small. So I just tried to pick a rational range. So I've actually created a data frame called data frame 1. And this data frame is going to have in it the just the guesses between 20 and 200. So let's go ahead and run that. So now you can see instead of having 864 guesses, we have 498. A lot of these 864, by the way, are missing. They're not values. So now that we've got that, let's take it and plot it. You know, do we really have a normal distribution? I don't know. So we're going to use Seaborn and go ahead and plot it. Look in our plots window. Oh, wow, look at that. That's actually not horrible in terms of a normal distribution. It looks very much like that. A couple of outliers out here. So I'm wondering if we take the mean or the average, how close we could get. By the way, the actual value of the calf was 65. So let's go ahead, print out a few, oops, love Control Z. Let's print out a few of these. See how close we get. Oh, wow. Our mean was 64.85 and our median was 65. So let's see what our accuracy was. (99.78% 99.78% accurate. So it kind of looks like we were keeping with the law of large numbers and the central limit theorem. We had, you know, a accuracy with 40 guesses of 95%. With, what was our number here? With 498 guesses, our accuracy was 99.78%. So the good news is, looks like math works. Statistics work. And I think this is a fun way to take a real-world example and use some creative Python code. And thank you to all of the folks, especially the gentleman who did the Selenium example, and take that and apply it to a real-world example. The prize in this case was a gift certificate for a pair of work boots, something I think a cattle rancher would appreciate. Unfortunately, my guesses came in way too late. I didn't have the I didn't see this video until it was actually the answer was published, but I thought it was a great example of taking something, doing some creative work in Python, and really kind of proving out the use case. So appreciate your time, everybody. Thanks for watching.